Hello, welcome to the online Gyro Lab. So the aim of the lab is to understand the gyroscopic effects and also to reinforce lecture materials. So the lab is composed of 3 parts. In the first part, we will observe and understand different behaviors of gyroscope. In part 2, we will deal with the free precession of the gyroscope, and you will take readings and measurements to calculate certain parameters. In part 3, you will also measure and calculate. And this part will deal with the gyroscopic reaction for the so-called force precession. So this is the gyroscope taken out from an aircraft of 1940s. It has a disc or rotor run by a motor inside the casing. This is a gimbal gyroscope. The gyro is mounted on a base and the base is free to rotate. And the gyro itself has a degree of freedom and it can rotate around inside the frame around that axis. So when the disc is not spinning, the gyro will simply fall. Let's see. But when you give the disc some angular velocity of spin, let's see what happens. So the disc stays upright when it rotates because it produces angular momentum. And angular momentum can be defined as the mass moment of inertia times the angular velocity of spin. And you can find out which way the angular momentum will work using the right-hand rule. You align your right and forefingers in the direction of spin, and the thumb should point out the direction of angular momentum. So in this case, the angular momentum will work in the direction shown, while you have an angular velocity of spin clockwise looking from left. So if we maintain a constant angular velocity of spin and no external torque is applied to the system, the disk should keep pointing in a direction in space with constant angular momentum. Now let's ask what will happen if we introduce some external torque to the system. And how can we predict which way the gyroscope will precess? Now we'll try to understand the phenomena in 2 ways. First way is the intuitive way. We'll try to predict the behavior of gyroscope by using our right hand. And then we'll understand in a proper way. Okay, so let's move on. So the intuitive way of understanding. So in this case, let's imagine the disk is rotating vertically and the angular velocity of spin is clockwise, looking from left, and angular momentum acting in the direction shown. Now let's try to understand how the gyro will react if we introduce a vertically downward force at the tip of the gyro arm. Now in this case, I want you to imagine a plane which is normal to the applied force. So let's imagine a horizontal plane, in this case, which is absolutely aligned with the direction of angular momentum. So it cuts the gyro horizontally in the middle. So in this scenario, I can say there is no net angular momentum acting anywhere in the top or in the bottom of the plane. All angular momentum is pointing in the direction shown, and I have just imagined a horizontal plane which is aligned with the angular momentum. So when you introduce a vertically downward force, the gyro will resist that force in that direction, because you can say that it didn't have any net angular momentum acting at the bottom of the plane. Instead, imagine that it shifts the angular momentum in the top of the plane because a force at a certain distance has been introduced in the system. Now, as we are using our thumb to point out the direction of angular momentum, align your thumb in the upward direction now, and your rest of the fingers should point out the direction of precession. So in this case, if we apply a vertically downward force, the gyro will start precessing counterclockwise, looking from top. So let's watch and try to apply this similar technique to predict the precession of the gyro when forces are applied from different directions. Now let's understand in the proper way. So when the vertically downward force is applied at the distance r, there is a torque produced. And by definition, torque is a vector cross of distance and force. So the direction of torque should be normal to both r and f, as shown here. Now we also know that torque is also equal to rate of change of angular momentum. So at time t, we have an angular momentum k. Now imagine a very small time step delta t after you introduce the vertically downward force. The direction of angular momentum will change from k to k plus delta k. And this change in angular momentum, delta k, shown in the picture will tend to act in the direction of torque. So that's the reason you have the gyro starts to precess counterclockwise looking from top when you apply a vertically downward force. Precession in other direction can also be explained in similar manner. So let's watch again.